Welcome to this training session. Myself, Venkat, consultant in technical process and technical safety with iFluids. This session we are going to deal with basic introduction to SIL assessment using LOPA. LOPA is layers of protection analysis. SIL assessment is done by 2 or 3 methods. Here we will have a brief about SIL assessment using LOPA method, and I hope this session will be useful to you, and by the end of the session you will be able to have a very good idea about the basic terminologies, and positively you will be able to start with working in the SIL assessment. Objectives of the SIL study: to establish the basis of the SIL study, to assess and establish the SIL for each SIF. This SIF, all this will go in the following slides in detail about what is it. The other objective is to record the proceedings and recommendations, and SIL study, SIL assessment and SIL study is the same, it's only for the SIS, that's ESD loops. So, what's the difference between HAZOP and SIL sessions? The HAZOP session looks at the positive side of the SIF. SIF is the safety integrity function and expects the SIF to perform its function successfully to avoid a hazardous incident from occurring. But in the case of SIL session, looks at the negative side, that's a failure or absence of a safety integrity function under the study. Explores the worst case consequence in absence of the SIF and establish the criticality rating SIL on this basis. So background for the safety instrumented system studies, that is SIS. So when the need for this SIL assessment raised, so we had so many incidents, major incidents, and specifically this SIL study is very specific for the petroleum industry, refineries, oil and gas and all this. So these I have just quoted 2 or 3 major incidents around the world. One was in 1984, the Union Carbide gas tragedy, that was in Bhopal, India. The second one, 1988, Piper Alpha offshore platform fire, North Sea, UK. And one more, Phillips 66 petrochemical complex explosion, Texas, USA. So the following slides are the pictures of just the Bhopal gas tragedy. After the tragedy, how it looked. This is the Piper Alpha accident. This is the Phillips 66 accident. So the common causes, similar to this, I could say it was around 20 incidents prior to starting the SIL. So failure of one or all of the systems, including process control system, operator based alarm system, safety shutdown system, mechanical protection system, fire detection and mitigation system, emergency response system. So one of these or more than one of these has failed, where we landed in a situation of a major incident. The common consequence, what is the common consequence in all? In Bhopal gas tragedy, more than 3,787 people have died due to MIC, that's a methyl isocyanide release, and many more died or suffered later. The air and the water bodies were polluted and the company had to shut their business in India. In Piper Alpha, 167 employees of Occidental Petroleum have died and entire offshore platform was burnt down, resulting in asset loss of $3.4 billion. In the Phillips 66 HDPE plant explosion, 23 personnel have lost their lives with huge damage to property and loss of business to the tune of $1.4 billion. So response by the international community, when these incidents have been repeatedly happening, There was a growing concern in the international community to enable codes and standards to enhance the health safety environment and avoid such incidents. In the USA, ISA SP 84 drafting committee was formed. Previously used MIL study were reviewed for being the starting point. In Europe, IEC standard drafting committees were formed. Shell standard were used as the go-by process. Reliability. Now we will move to this, our part of the part. Reliability. What is reliability? I thought by the word itself explains the probability that a component, part, equipment or system will satisfactorily perform its intended function when it is required to do so, under given certain circumstances such as design limits, environmental conditions, limitations as to operating time, frequency and the thoroughness of maintenance for a specified period of time. So reliability includes for the important aspect the device intended function must be known, what this device is designed for, what's supposed to do. So when the device is required to function, when the device is required to function, must be judged. Satisfactory performance must be determined and specified design limits must be known. Okay. So after the reliability is how much we can rely upon it. But reliability for what? For the risk. What is risk? Risk is defined as a combination of the probability of occurrence of a hazard, a harm, and the severity of that harm. So resulting in the failure of the system. Risk has impact on the personnel, on the asset, on the environment and reputation of the organization. So these are the standard codes which are used for SIL assessment. IEC 61508 is a common one, IEC 61511. What are they? Standard for functional safety of electrical, electronic, programmable electronic safety related system is IEC 61508. 61511 is for the safety instrument systems for the process industry sector. So we are using the LOPA method, already we have mentioned that, and they are grouped into three phases. The SIL assessment is the analysis phase, verification is the realization phase, and the validation is the operation phase. Here we are going to deal with only assessment. So just you can go through this. I think it is self-explained and no need to explain about the IEC 608, the concept overall of definition, hazard and risk analysis. Next comes the overall safety requirement, then the safety requirement allocation. So those in yellow are the analysis phase. Those in the green is overall planning, operation and maintenance planning, validation planning, instrument installation and commissioning planning, and safety related systems realization, safety related systems, other technology realization, external risk reduction facilities realization. So this is the realization phase. So next comes the overall installation and commissioning. Then comes the overall safety validation. So now we have finished the analysis phase, realization phase. Next comes the operational phase. When it comes to the commissioning, installation and commissioning and overall safety validation, overall operation and maintenance, modification and retrospect, and the decommissioning. So this is the cycle of 61508. 61511, similarly, I think you can go through this, and relationship between these two. So this is, as we already explained, all sector safety system standard. This is 6.1. It is about the suppliers and the devices. For example, you choose a control valve and an ESD or a thing. So how to choose it? So you need to see the SIL rating, and based on that, is this equipment or a device is designed to handle that. So there comes that. So process sector safety standards are for the users. Okay. So let us have a small thing about the basic terminologies we are going to use in this presentation. Safety integrity level is the SIL. Safety instrumented function, SIF. Safety instrumented system, that is the SIS. It's about the interlock. Probability of failure on demand is PFD. LOPA already we have told, layers of protection analysis. Process hazard analysis is PHA. Independent protection layer, IPL. So these are normally not used in the assessment. It's used in the next verification page just to have an idea. It is mean time to failure, MTTF, mean time between two failures, 2 or 3 failures, that is mean time between failures, mean time to repair. So these formulas are used to determine the mean time between failure and mean time to failure. Basic terminologies, again we have a few more things. Safety. Safety, what is safety? Freedom and unacceptable risk of harm. So freedom from. So unacceptable risk of harm. I think I am clear in this. Hazard, potential source of harm. Risk is a combination of probability of occurrence of a harm and its severity. So what is the chance of this occurrence and how severe it's going to be? Combination of this into that is going to give you the risk. Tolerable risk is the acceptable risk in a given context based on the current values of the society. So risk is frequency of accidents into consequence. Risk reduction factor is RRF, 1 by probability of failure on demand. Okay. PFD average is frequency of tolerable accidents by frequency of accidents without protection. Now, SIL assessment. So SIL is safety integrity level, we already discussed, and SIF and SIS are these systems which we are going to do the assessment. What is SIF and what is SIS? A safety instrumented function, SIF, is a built-in operation of an equipment or system that takes the unit to a safe outcome if predetermined conditions are not complied. So it is clear for you, I think. So predetermined condition, what is it? This tank is supposed to operate that at that level. So for that we have a control valve or a level indicator. So this level indicator is going to give a signal to the control valve to open or close to maintain that level. So the predetermined condition is to maintain the tank level at 80%, let's suppose. In case the level is going to go down or go up, what this control valve is supposed to do? That is, it's supposed to open when it is low, it's supposed to close when it is high. So this is a small loop which is called the SIF. Safety, the system involves 3 elements of logic solver, sensor and the final element. So sensor is what? The level transmitter. What is the logic solver? Sensor senses what is the level. It gives the feedback to the logic server. Logic solver in turn turns the final element, that is the control valve, to open or close position as required. Safety instrumented functions are also known as emergency shutdown systems and safety shutdown systems. So we'll go through all this in the future slides. SIS, a safety instrumented system, is a combination of sensors, logic servers and the final element that performs 1 or more safety. So 2 or 3, or there is no limitation for the number. A combination of SIF, safety instrumented function, is called as SIS, safety instrumented system. So what is the difference between SIF and SIS? From this picture you can see SIF is, there is a sensor, there is a logic server which is going to close or open that XV1, XV2. So it is in. You can see in the SIS we have given by 3 colors, blue, yellow and pink. So the same logic server takes signals and gives the command for the valve to close or open from various sources, and the SIF is a single system. SIS is a combination of all the 3 SIF SIF loop 1, 2, 3. All three combined in the same logic server, that is called a SIS. So now availability. Total availability is equal to 1 minus PFD average safe failures, PFD average dangerous failures. That S and D stand for safe failure and dangerous. Safety availability is 1 minus PFD average of dangerous failures. So what is it? Where PFD average S stands for average probability on demand to the SIS for safe failures. Same way for dangerous failures, PFD average D. Example, a shift is characterized as follows. PFD average safe, that is average probability on demand to the SIS for safe failures, is equal to 0.001 per year. That is 1 in 1000 years. So average dangerous failures is 1 in 10,000 per year. So total availability is 1 minus PFD average S plus PFD average D, that is 99.9%. Same way for the safety availability. So failure rate. This is also mainly used for the SIL verification. So failures detected, undetected, and this lambda D is dangerous detected and dangerous undetected, the sum of it. So we are not going to use these things in the SIL assessment. Just for an idea, I will leave it to you for going through this. So examples of SIF, safety integrity function in process industry. Flame failure in a furnace initiates fuel gas ESV to close. So when there is a flame failure, we are not supposed to allow fuel gas into the furnace. So there will be an ESD, it will close. So this is an example of a SIF. High level initiates the compressor shutdown. Loss of cooling water to reactor stops the feed and depressurizes the reactor. So this is a simple pictorial representation of the SIS. So there is you can see the picture of a transmitter. So that's for measuring. The middle picture is the logic server and the final response is a control valve. So understanding SIL. What does SIL mean? Safety integrity level. A measure of probability of failure on demand. So for every equipment there is a chance of failure. So when it is required to work, when it is supposed to work, it fails. That's what is called probability to fail on demand of the SIF. So it's a statistical representation of the integrity of the SIF. So integrity, you know the meaning, right? So integrity means we have to rely on it and how far it's going to satisfy its function. So statistical representation of the integrity of the SIF when a process demand occurs. A demand occurs whenever the process reaches a trip condition and causes the SIF loop to take action. So a trip condition occurs in both cases, when it reaches high or when it reaches low. I mean high or low. So SIL is rated between 1 to 4. It is a number. SIL 4 is the highest and SIL 1 is the lowest. So SIL 1 is the safest and you can say SIL 4 is more unsafe. So SIL classification, integrity levels as per the IEC standards. So SIL level 4, I said SIL level 4 is a high risk. So probability of failure to demand could be more. So now the risk reduction factor. So here we need to choose an instrument where it could reduce the risk. So that is the risk reduction factor. That means high integrity. So as per the instrument, as far as the instrument is concerned, SIL 4 is the most safe instrument because it is designed to handle the high risk level of SIL 4. So when it comes to SIL level, SIL 4 is more risky. When it comes to an instrument which is going to handle the risk reduction, there SIL 4 is more safe instrument. Okay. So this is how it's. So SIL 1, 2, 3, 4 probability category 1 in 10 to 1 in 100 SIL 1. What is that? Probability is less. Probability of what? Probability of failure. So number 2 is 1 in 100 to 1 in 1000. Number 3 is 1 in 1000 to 1 in 10,000. Number 4 is 1 in 10,000 to 1 in 100,000. So 1 in 10 means the function will fail once in a total of 10 process demands. So 10 times there is a demand, there is a chance of one failure. 1 in 1000 means the function will fail once in a total of 1000 process demands. So SIL determination, I told you earlier, there are various methods. Safety layer method, risk graph method, calibrated risk graph method, event tree, or the LOPA. So here we are discussing about layer of protection analysis method. LOPA has 5 basic steps. LOPA is a simplified tool for analyzing and assessing the risk. Consequence identification. Identify the initiating event of the scenario and determine the initiating event frequency, events per year. So, first consequence identification, initiating event of the scenario. So, what is a failure of a indication or a failure of a control valve could lead to that will be the initiating event to cause a hazard. So identify the IPL. IPL is independent protection layer. So what are the independent protection layers available and estimate the probability of failure of demand for each independent IPL. So estimate the risk of the scenario. So we have to identify the consequence, then the initiating event, then the IPL, then estimate the risk of the scenario. Compare the calculated risk with the company's tolerable risk criteria. So each company will be having their own methodology or their own documentation for the tolerable risk criteria. Study basis. Initially, the worst case consequence has to be established without applying any credit to the protection layers. Why we are doing it? We are doing an assessment. So, if this fails, what's going to happen? The worst case. Then we see the consequence and then we go for the what is available and what is the protections available, like that. So, the SIL rating for the SIF has to be established without giving credit for the SIF under study. So, we take a SIF to do the assessment, safety integrity function. If it fails, what's going to happen? So, that's like that. Pre-alarm could be an IPL only when operator takes action within 10 minutes. PSV is an IPL if it is sized for the governing concern. Only one time IPL credit could be applied for one type of IPL. Independent SIF could be applied as an IPL only when the PLC is SIL 3 rated and the sensors and the final elements are completely independent and not shared. So input documents required, SIL assessment, for SIL assessment, PNIDs, cause and effect, HAZOP study report if there is anything done before. Normally any SIL is followed by a HAZOP study. So company guidelines for the HSE guideline document, SIL assessment standards and procedures with risk assessment matrix and tolerable risk acceptance criteria. Heat and material balance or composition, example toxic gases like H2S, emergency shutdown procedure and control narrative. So concept of layers of protection. So in the white portion in the bottom you can see a process. basic process control. That is a control valve, and it is a simple control loop, a sensor and a controlling element. Alarms. So when it is going to cross the desired uh, level what you want to have, or a pressure or a temperature, so when it's going to cross that, operator operator intervention is required when you get an alarm. Next comes the SIS, safety integrated system, instrumented system. So here, after the alarms, this system is going to trip the system as per the how it is designed. If that also fails, next comes the layer of protection is the physical protection. It's like a relief device or a dike, or so physical protection. You can see relief devices and the dikes. Still something happens, there will be the next layer of protection is the emergency, plant emergency response. And if it is going to be in a wider perspective, this harm is going to harm in a wider perspective, comes the community emergency response. So reducing risk with the multiple protection layer. So risk, you can see it's growing in the x-axis. In a process there is risk. You see from the right to left, risk inherent in the process is that is showing the highest risk. So BPCS is a process control system, basic process control system. So that is a simple control group. Then comes the alarm, safety integrated system. Then comes the physical protection device, and any other things we could add will bring the risk to zero level. So only BPCS is available, you see the risk is almost 90%. But when BPCS with the alarm is available, it still reduces the risk. If the SIS is also available, it's less than 50%. So with the mechanical protection, it becomes almost 80 and other. So risk reduction using various types of, you can see it very clearly from here. The increasing risk is from left to right. So method A, you see one non-SIS IPL1. So that means you don't have a SIS, just a control system. So you see there is a process risk is high. So when you have in the method for all the four, the process risk is very less. So components in a scenario, initiating event, that is cause. What is the cause for an event? So common failure or a human error. Enabling events and conditions, conditional modifiers, probability of ignition, probability of fatal injury, probability of personnel in the affected area. So all these are conditional modifiers. So we have three IPLs, independent protection layer. Number one, still there is a chance. Number two, number three. So finally comes the consequence. So typical IPL, what are the IPLs? Control system, PCS. You can say BPCS, that is the control group. Then alarm, same thing what we have seen. Pressure valve, what was written there, it's in a pictorial representation. So this is the tolerable event frequency. So it is given in a little more detailed thing. This will be used in the analysis phase. So the severity is 1, 2, 3, 4, 5. So we have to see the severity which is going to affect the people or the environment or the asset. So based on this we will be giving the rating there. Same way the frequency. So there also you see people's environment and safety. So one incident in a year or whatever it is, we have to have our perception. If this is happening, it could affect what. So based on this we calculate the frequency. So what are the initiating events? An initiating event starts the chain of events that leads to an accident. Okay, so any one small incident only will trigger the thing. So immediately action is taken or some protections are available, all the further consequences are avoided. So if that is ignored, or that is not available, or whatever it may be, finally we land in a catastrophic scenario. So an initiating event starts the chain of events that lead to an accident. Initiating events can be a failure of a piece of equipment, control system, or an human error or operator error. Examples are failure of a cooling water pump, starting of the wrong pump, inadvertent closure of a valve. So, one initiator tripping multiple final elements. So, initiator, you can see one initiator is there is a logic server. So, the same initiator is giving signal to 1, 2, 3 functions, function 1, 2 and 3. One initiator tripping multiple final elements. So what does it mean? Why do we show this? One initiator fails, there is going to be a risk for 3 functions. So here multiple initiators tripping one element. So this is more safe, right? So there are 1, 2, 3, 4 initiators passing through a logic to trip only one final element. So SIL using LOPA methodology, whatever we explained in this past slides is given as a representation here. So inappropriate initiating event, examples of inappropriate initiating event. What is it? Inadequate operator training certification, inadequate test and inspection, unavailability of protective devices such as safety valves or overspeed strips, unclear or imprecise operating procedures. Initiating events frequency estimation, failure rate data sources, company historical failure data. If we have a record, that will be fine. Vendor data, third parties, and the standards. So this is the CCPS which we are using for the assessment. Conditional modifiers and enabling events. What does it mean? Conditional modifier is an action or event that can reduce the probability of an undesirable event. Enabling event do not directly cause the scenario. Enabling event examples is enabling event failure of a control loop. So that is the initiating cause caused by the closure of an LCV. So this is the enabling event. Enabling event here is the closure of the LCV. So event failure of level control loop is the initiating cause, leading to what? Raise in the KOD level, which again liquid carryover to compressor, which causes again mechanical failure of compressor, causes loss of containment and injury and fatality to the personnel. So this is a small table for showing the conditional modifier and enabling events. If this type of conditional modifier for ignition probability, one event in 3 probabilities, once in 3 years, once in 5 years for operator presence of 50%. So it goes on like that. Same way, the enabling events also, it's given. IPL. All IPLs are safeguards, but all safeguards are not IPLs. Okay? An IPL has 2 main characteristics. How effective is the IPL in preventing the scenario from resulting to the undesired consequence? Is the IPL independent of initiating event and the other IPLs? These things we have to see while dealing with IPL. Typical layers of protection are BPCS is a basic process control system, alarm and human intervention, safety instrumented system, SIS or an interlock, physical protection such as PSV. Independent protection layers, safeguards are not usually considered IPLs. Training and certification, procedures, normal testing and inspection, maintenance, communication, signs, fire protection manuals and firefighting, etc. Plant emergency risk. These are not usually considered as an IPL. Characteristics of IPL. Specificity. An IPL is designed solely to prevent or to mitigate the consequence of one potentially hazardous event. A runaway reaction, release of a toxic material, a loss of containment or a fire. Multiple causes may lead to the same hazardous event and therefore multiple event scenarios may initiate action of one IPL. Independence. An IPL is independent to other protection layers associated with the identified danger. Dependability. It can be counted on to do what it was designed to do. Both random and systematic failure modes are addressed and the design. Auditability is it's designed to facilitate regular validation of the protection functions, function testing and maintenance of the safety system is necessary. So this is again a small table which we are using for the assessment. This here SEL is safety, environment and economic. You can go through this. Overall SIF showing SIFs. This is a small calculation for SIL. You can see this and the following slide the difference. PSHH, that is the thing which we are going to take into consideration if it fails. So initiating event will be PCV 501 failed open. Okay, this PCV fail opened. What's going to happen? Independent protection layers are high protection alarm. The level is going to be high. There is an alarm. That is one of the IPL. High pressure alarm. That is one of the IPL. And probability of failure on demand is 0.1. So the actual frequency will be 0.1 per year into 0.1. Okay. That is initiating event into IPL. So that will become 0.01 per year. Okay, 1 in 10 years. So the risk reduction factor is calculated by actual frequency divided by tolerable frequency. That comes to 1000. This is SIL 2 rated. And anywhere in the world you can see almost 90% of the things are SIL 2 rated. We can have a better rating like SIL 3 and SIL 4, but we have to work out the commercial part of it also. It's all to SIL 4 is practically not possible. SIL 3 you need to invest more on that. So SIL 2 is safe. So SIL calculation. So I told you the previous slide and here. What is the difference? There is one more PSV added. Right? So you have one more IPL other than the level high and the pressure high alarm. So you see there it was SIL 2. Now here we have reduced the risk reduction has been reduced to SIL 1. Samples of a SIF loop PNID. Here we have marked the SIF loops. It will look like this. And this is a small example of a LOPA worksheet. So LOPA worksheet formula, unmitigated event frequency, UEF. Frequency of an unwanted event taking place without any IPL present. This is calculated as per consequence category. UEF is automatically calculated based on the following equation. UEF equal to sum of the initiating event frequency into enabling event into conditional modifier probabilities. So same way the mitigated event frequency of an unwanted event taking place with consideration of independent IPLs. This is calculated per consequence category. MEF is automatically calculated using the following equation. MEF equal to sum of initiating event frequency into enabling event into total probability of failure on demand for all IPLs as per the initiating event into conditional monitor modifiers probabilities. So you can go through these abbreviations again. BPCS, what is it? Just the abbreviations of what we have used in this presentation. And thank you very much for being patient and listening to me. Hope this would have given a better understanding. And iFluids is always welcome to take any doubts from you or any clarifications. Always you can approach us. Thank you very much.